All right, so the previous video I recorded on quadratic functions, the sound was really bad, so I'm redoing the video, okay? With quadratic functions, we just learned about quadratic functions and what they are and what they look like. And one of the things you really need to understand is that there's two different forms that quadratic functions can be written. There is vertex form and there is standard form. Now, with each form, notice that there are some different letters, like in vertex form we have H and K, where in standard form we have A, B, and C. And of course we have the A in vertex form and it has the exact same meaning in standard form. But the B and the C have different meanings than the H and the K. Excuse me. So that's why we have different letters here, because they have different meanings. And in each problem you can use them to find different things. So understanding those things helps you kind of identify what the graph of the quadratic function is going to look like. So the vertex form, I'm so sorry. In the vertex form, the line of symmetry is where x is equal to h. So again, the vertex form where you have x, here is the h, and the vertex form, that tells you the line of symmetry. Well, in the standard form, it's a little bit more complicated. It's not as obvious. It's not difficult. It's got to takes a couple more steps. But the formula is that the x equals, that's the line of symmetry, it's a vertical line, is negative b over 2a. And so that's going to be your negative b over 2 times whatever your a is. All right, now to find the vertex of the parabola, we're going to use the standard form to do that, and it's a coordinate, so that's why we have these parentheses here, and so it's a coordinate, it's separated by a comma. The idea here is that you figure out what your vertex is, which if you think about it, if you're looking at a parabola, the vertex is going to be where the graph is changing directions. So like my numbers are decreasing, 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 and then when I get here, my numbers start increasing. So that vertex is where they change direction, where my numbers start changing direction, or my y values, I guess I should say, start changing direction. Well, the vertex, this is also the line of symmetry. Sorry, that's not a straight line. So this line of symmetry, let's say this line of symmetry is where x is equal to 2. Well, I don't know what this y value is right here, but I know that whatever my y value is, it's going to be 2 comma something, because it goes through the line x is equal to 2. So that's what's happening here. You're figuring out what your x value is based on your line of symmetry, and then you plug that back into the equation and you figure out what your y value is. So, and of course I'll do an example in a second, okay? So looking at the equation, whether it's the vertex form or the standard form, you can tell quite a few things from the graph. You can use that to find out how the graph opens, meaning if it opens up or if it opens down. And so what you can do is, if you have the equation in standard form, f of x is equal to ax squared plus bx plus c. If your a is positive, your graph is going to open up like this. If your a is negative, your graph is going to open down like that. Okay, so the a, that gives you your direction. It tells you how your graph opens. And then, of course, we just talked about line of symmetry. You use that formula to find the line of symmetry. You use the formula to find the vertex. Your y-intercept is your c. Your c is the y-intercept. And then once we know all of these things right here, we can then graph the equation. And from the graph, we can determine the maximum and minimum, which is also tied in with the vertex. And I'll talk about that as well. And then we'll also talk about the domain and range. You can find the domain and range. And again, you can even tell that without actually sketching a graph. You can tell that by your vertex. All right, so let's start with this equation right here. We have y is equal to negative x squared plus 2x plus 1. So first of all, a couple things I notice. Because of this negative, I know that this graph is going to open down. Okay, I don't know exactly where on my coordinate plane yet, but I do know that it's going to open down because of that negative sign. All right, something else I notice is I also notice that the y-intercept is positive 1. So I know that on the y-axis at positive 1, this parabola, that's what this is called, this U-shape in the quadratic function, because all quadratic functions have this U-shaped and they're called parabolas, that I know that the parabola is going to cross the y-axis somewhere. I don't know what point on here, but I know it's going to cross the y-axis at the 1. What else do I know? Okay, so then I can find my line of symmetry. And so my line of symmetry is going to be x is equal to negative b over 2a. Apologize about that again. Negative b over 2a. Well, if I'm looking here, I need to first identify that a is negative 1, because remember, it's understood that there's a negative, or that there's a 1 in front of the x when there, or the coefficient is 1 when you don't see a number. So that's a negative 1 here for a, that my b is positive 2, and my c is positive 1. So I'm going to go through and I'm going to plug these into this equation here. So I said that my x is negative b over 2a. So it's going to be negative 2 over 2 times negative 1. Well, if I simplify that, that gives me negative 2 over negative 2, which is positive 1. So at x is equal to x is equal to positive 1, that's my line of symmetry. Let's see, what else do we know? So now that we know that on the graph, I said we know that it opens down, and we know that this is on a coordinate plane. Oops. Actually, let me do it this way. If this is a coordinate plane, and this is where x is 1, I know that this is my line of symmetry for my parabola, and we already said it crosses the y-axis at the 1. So we know the graph is going to be shaped like this going down. And again, I'll sketch it for real on the graph in a second. But this gives me some things about the graph, okay? So now I want to find the vertex. And so we know our vertex is 1 comma something, because if the line of symmetry is at 1, the vertex is going to be the highest point or the lowest point, because it's where it changes direction. So here my numbers are increasing up to here, and then they start decreasing that way. So the vertex is where they change directions. So my x value I know is going to be 1. So I want to figure out what my y value is. Well, what I do is I am going to plug in this x into this function right here to help me figure out what my y is, because that's what a graph shows. A graph shows all your solutions. Well, if x is 1, whatever y is, that's a solution that's on the graph, and it just happens to be the vertex. So I'm going to plug that in. So y is going to be equal to negative 1 squared plus 2 times 1 plus 1. So y is 1 squared is 1. Remember, you got to follow the order of operations and do exponents first, then multiply it by the negative to give me negative 1, plus 2 times 1 is 2, and then plus 1. So therefore, y is negative 1 plus 2 is 1, 1 plus 1 is 2. So my vertex is 1 comma 2, which that sounds about right, right? We went over 1 up 2, okay? What else can we tell about this graph? We can tell, well, let me graph it and then we'll talk about some more about it. Okay, so we said that the vertex is at the point 1 comma 2. That's our vertex. And we said that it crosses the graph at y is equal to 1. We said that this is, remember, this is the y-intercept where y is equal to 1. And then we also said that the graph went down because of the negative sign here. Well, something to think about is that if this is the line of symmetry for this graph, if this line, if this point right here, should change. If this point right here is 1 away from the line of symmetry, which is, then this line, there's going to be a point also over here that's 1 away because it's symmetrical. And so I can kind of use that to help me sketch a graph. Again, this isn't going to be a super exact graph. I don't know exactly what's happening over here on this side, but it's just a sketch of a graph to get an idea of it, okay? So now that I'm looking at this graph, I need to decide if it has a maximum or if it has a minimum. This graph does not have a minimum. Because it's going down, There is no minimum. It's going to go on forever. If you can find the lowest number it goes, I can find one even lower. It's just going to keep going down. So there is no minimum here for the graph. So therefore, there is a maximum. And this point right here, that is the maximum. Your vertex is always going to be your maximum or your minimum. So the graph does have a maximum. Now, the reason that this is important is because where the maximum is, or the minimum, but for this problem specifically, the maximum, that tells you about the range, okay? Now, if you remember, domain is all of your x values. So domain is all of your x values, and range is all of your y values. So if I'm looking here at this graph and I want to decide what the range is, I know that this is 2 right here. This is the number 2. My y values are not going to go past it because it stops right here at the maximum. So 2 is the highest number that my range can be. So my range can be any number less than 2. So the way we write it is we say that the range is, for all y values, y is going to be less than or equal to 2. That's our range for this particular problem. And the domain is going to be all real numbers, because I can plug in any number to this original function right here and I can get an answer. So I can plug in any real number, so the domain is all reals. And it doesn't look like it now, but this graph is actually going to it doesn't go out this dramatically, but it's going to keep getting wider and wider and wider and wider and wider, and it's just going to keep going down. So you can plug in any x value and find a solution, okay? So let's do another one. So we have 2x squared plus 8x plus 6. So a couple of things I noticed by looking at it. I know that it's going to open up because this is positive a, right? So my a is 2, my b is 8, and my c is 6. So because my a is positive, I know that my graph is going to open up. I know that it is going to cross the y-axis at positive 6. So my y-intercept is positive 6. I can find my line of symmetry by doing negative b over 2a. So I'm going to say negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2. So at x equals negative 2, that is our line of symmetry. Now for finding our vertex, remember our vertex, the x value is going to be the same thing as the line of symmetry that we just found, but now we need to find our y value. So to do that, we're going to plug in 2, we're going to plug negative 2, this number right here, into our original function. So that means y is equal to 2 times negative 2 squared plus 8 times negative 2 plus 6. So y is negative 2 squared is 4, 2 times 4 is 8. Plus negative 16 plus 6. 8 plus negative 16 is negative 8. Negative 8 plus 6 is negative 2. So at negative 2, comma negative 2, we're going to have a vertex, and it's going to open up, and it's going to cross the y-axis at the positive 6. So let me go ahead and graph those things, okay? So we said, I'm totally lost it. Okay, so the y-intercept is positive 6. 1, 2, 3, 4, 5, 6. At negative 2, we have a vertex. Excuse me. And we know the line of symmetry is this beautiful crooked line. Sorry, that's terrible. Let's do a real one. There we go. All right, so there's our line of symmetry. And I always like to figure out, because, you know, I can tell that this graph is going to do this, but on the other side, it's a little bit difficult. But again, see how it's 2 away right here? So that means it's going to be 2 away from this side as well, because this is a line of symmetry. This yellow line is a line of symmetry. So I can't draw straight to save my life, but wow, that was bad too. Let's go this way. See it. Wow, it's this tablet, y'all. I normally can draw pretty straight. Oh my gosh. There we go. It's not perfect, but it'll do. Okay. So a couple things about the graph. We can tell, and these blue lines right here in the middle really shouldn't be here, so sorry, but that's okay. So we can tell that the graph has a minimum because it does stop here. It does not have a maximum because it opens up and it's going to go on forever going up. So there is no maximum. So this point right here, this vertex, is going to be our minimum. And then we can also tell that the range, because the minimum is here at -2, that our range, all values of y are going to be greater than or equal to -2. Any value greater than or equal to -2 can be a y value solution to this graph. And the domain, that was the range, the domain is going to be all real numbers. Again, you can plug in any number here and you can get a solution. So the domain is all reals. All right, let me do one more. What I want to point out about this one is, standard form is ax squared plus bx plus c. Well, if I'm looking at this graph here, I don't see a bx plus c. So I'm going to rewrite this just so that you can see what it would look like. It would be -1/2 x squared plus 0x plus 0. Okay, so that's standard form. I filled in the b and the c. And the reason that helps is this tells you that your a is -1/2, your b is 0, and your c is 0. So let's go through and let's find those things. Okay, so we're going to find, first of all, the line of reflection, which is -b over 2a. So it's going to be -0, which we know there's no such thing as, 2 times -1/2. So this is going to be -0 over 2 times -1/2 is -1, but this is going to be 0 over +1 because of the two negatives right there. So 0 over 1 is going to be equal to x. Well, 0 over 1 is just 0. So our x, our line of symmetry, is going to be where x is 0, which is the y-axis. Okay? All right, then we want to find our vertex. And our vertex, we know it's going to be 0, something because the vertex is somewhere on where x is equal to 0. That's our x value, but now we want to figure out what y is. Well, when we plug it into y is equal to -1/2 of 0 squared, 0 squared is 0. 0 times -1/2 is also 0. So the vertex is at 0, 0. And because there's not a I can't say not a y-intercept, because the y-intercept is 0, we're going to start at the origin. And because it's negative, it's going to open down. Okay, so let's graph this. The y-axis, or where x is equal to 0, is our line of symmetry. The point 0, 0 is our vertex. And where 0 is also the y-intercept. So, and then again, we also know the graph opens down because of that negative. So again, I don't know exactly what this graph looks like, but I know it does something like that. You can get a more exact idea by plugging in numbers. You can create a table and say, okay, well, if x is -1, what is y? When x is -2, what is y? And so on. And you can get a better idea of what this graph is going to look like. Oh, and I didn't even talk about maximum minimums. Okay, so this graph, because it's opening down, there is no minimum. It's going on forever going down. Okay, so this is a maximum. The vertex is your maximum. The domain is going to be all real numbers again, because I can plug in any number to the equation and I can get an answer. And the range is for all values of y. Y is going to be less than or equal to 0. My highest y value is 0. Everything else below it is also an answer.